So when we're talking about atoms, I told you that any atom with the same number of protons is that atom. And here's what I mean by that. Let's say we're talking about beryllium, okay? Now, any atom that has 4 protons is beryllium, okay? Any atom that has 4 protons is called beryllium. But the fact is, there are more than one types of beryllium atoms. What do you mean? This atom right here, if we were going to talk about it, we would say this beryllium atom has 4 protons. That pen's not working too great. We would say this beryllium atom has 4 protons, so that makes it beryllium. Then we would see this 9 down here. We would say 9 minus 4, it has 5 neutrons, okay? So this is beryllium, all right? But guess what? There are other atoms of beryllium that have an atomic mass of 10. And those atoms are still beryllium, but they have, guess what? 6 neutrons. Now the difference between this beryllium, which has 4 protons, and the other one is just the number of neutrons. So beryllium that has 6 neutrons and a mass of 10 we would call that beryllium 10-10. And the most common beryllium atom is actually beryllium 9. Okay? The most common one, because that's the one that you see on the table. The one that you see on the table is the most commonly occurring isotope. The most commonly occurring isotope. All right? So when we talk about isotopes are atoms that have different numbers of neutrons. It's the same atom, but has different numbers of neutrons. Those are called isotopes, okay? The mass number is different, that's all. Now usually, the difference of 1 neutron doesn't make much of a difference in an atom. Unless either it's a very, very small atom, well, that's about it. Having or missing 1 neutron doesn't change much about an atom, usually. It can. All right? So this is why when you see the periodic table and you look at the masses of all the atoms, that's why they're this rounded off number. Phosphorus, you can see, is 30.97. So that will tell us that most phosphorus atoms weigh 31. But there are many, many phosphorus atoms that only weigh 30. And if we average those out through a mathematical process, the average is 30.97. The reason we have all these decimals is because all of these atoms exist as isotopes. Okay? Now, an isotope doesn't mean that that one's dangerous. It just means it's different. So, fluorine is usually 19. So the most common isotope of fluorine has an atomic mass of 19. Or in other words, fluorine 19 is the most common version of fluorine. But fluorine 18 exists too. They're both isotopes. Okay? It's not like the more uncommon one is called the isotope. They're all isotopes. That's just a word. Does that make sense to you? Okay, so when we look at these isotopes, here's a really good example. Carbon-12 is the most common version of carbon. It's the most common isotope. But you've probably heard of carbon-14 from watching television, right? We use it to date organisms that are anywhere between 50,000 years old or younger. We can date how long ago they died pretty accurately with carbon-14. But these are 2 different isotopes. The red and white here represent protons and neutrons in the nucleus, okay? So carbon 12 and carbon 14. Carbon 12 and carbon 14. Well, they're different. What is the difference between carbon 12 and carbon 14? They both have 6 protons, but carbon 12 has 6 neutrons. Carbon 14 has 8 neutrons. That's why it's carbon 14. Does that make sense? Now, here's the way we write isotopes. We usually put the mass number on top over the atomic number and then the atomic symbol. That's how it's usually done, right there. So, again, you people in here, you're about to see this again. So don't fret over it too much. I know I'm going too fast for you to write this down. All right? People at home can pause it. All right? So check this out. Here is, let's say, sulfur 32. 32 over 16S, right? Everybody like that? And then what if we had 34 over 16S? This is called sulfur 32. It's the most common by far. You write sulfur dash 32. And this would be sulfur dash 34. What's the difference? They both have 16 protons. But this one has 16 neutrons. This one has 18 neutrons. Right? How would I know? Subtract those two numbers. 34 minus 16 is 18. And right here, 32 minus 16 is 16. 16 neutrons, 18 neutrons. These are two different isotopes of sulfur. This one's sulfur 32, the most common. This is sulfur 34, less common. Does that make sense? That's it. Okay? That's all there is to isotopes. Isotopes aren't like a complicated deal. So what you're going to see later is the last assignment you'll have today will be a little chart like this. And we'll do more isotopes tomorrow. You're going to have a little chart like this, okay? And then you'll be able to fill it out. Let me show you. I'll try to get this exact chart to you as the homework, or one exactly like it, as close as it can be. Let's talk about how we would fill one of these out. People at home, you can watch too. Ready? All right. All right, somebody's got 44 protons, okay? That means that the atomic number is also 44. Because the atomic number is the number of protons. Does that make sense? All right? If the mass number is 102, then how many neutrons do we have? 102 minus 44, right? 58. Now, if we have 44 protons and the atom is electrically neutral, then we have to have 44 electrons. These two numbers have to be the same. Because these are positive, these are negative. Does that make sense? Right? So 44, got to have a 44 here. All right? What is the nuclear charge? The nuclear charge is how positive the nucleus is. So if there are 44 protons in the nucleus, and all the other things in the nucleus are neutrons, then the nuclear charge has to be positive 44. So in other words, the protons, the atomic number, and the nuclear charge are all going to be the same thing. Right? Does that make sense? The charge of the nucleus. Are there any electrons in the nucleus? No. So the nuclear charge is going to be the number of protons. Nucleons. That nucleons are words for protons and neutrons. Particles that are in the what? Nucleus. So 102. So in other words, the nucleons and the atomic mass number are going to be the same thing, right? And then the element symbol. Number 44 on the periodic table. We look up on the periodic table, we see number 44, Ru. Does that make sense? So that'll be your last homework for today, is a simple sheet like this that you fill out the chart. Of course, you're going to type it in red, right? All right, cool. And we'll review isotopes tomorrow.